Reasons to optimize your network's performance. So why do we have networks anyway? I don't mean this in a historical sense, I mean pragmatically. The reason they've become such a precious resource is that our world has become smaller and more connected. We need a way to keep in touch like never before. Networks make accessing resources easy for people who can't be in the same location as the resources they need, including other people. In essence, networks of all types are really complex tools we use to facilitate communication far afar, and to allow networks of all types are really complex tools. In essence, networks of all types are really complex tools we use to facilitate communication from afar and to allow lots of us to access the resources we need to keep up with the demands imposed on us in today's lightning paced world. And we use them, we do a lot. And when we have many people are trying to access one resource like a valuable file server or a shared database, our systems can get bogged down or clogged as a freeway at rush hour, just as road rage can result from driving on one of those not so expressways. Frustrated people can direct some serious hostility at you if the same thing happens when they're trying to get somewhere using a network that's crawling along at snail pace. This is why optimizing performance is in everyone's best interest. It keeps you and your network users happily humming along. Optimization includes things like splitting up network segments, stopping unnecessary services on servers, offloading one server's workload to another, and upgrading outmoded hardware devices to newer, faster models. I'll get exactly how to make all this happen coming up soon, but first I'm going to talk about the theories behind performance optimization and even more about the reasons for making sure performance is at its best. In a perfect world there would be unlimited bandwidth, but in reality you're more likely to find Bigfoot, so it's helpful to have some great strategies up your sleeve. If you look at what computers are used for today, there's a huge difference between the file transfer now versus those transferred even 3 or 5 years ago. Now we do things like watching movies online without them stalling. We can even send huge email attachments. Video teleconferencing is almost more common than Starbucks locations. The point is that the files we transfer today are really large compared, so we sent back and forth just a few years ago, and although bandwidth has increased to allow us to do what we do, there are still limitations that cause network performance to suffer miserably. Let's start with a few reasons why you need to carefully manage whatever amount of precious bandwidth you've got. Latency sensitive. Most of us have clicked to open an application or clicked a web link only to have the computer just sit there staring back at us, helplessly hanging. This sort of lag comes when the resources needed to open the program or take us to the next stage are not fully available. That kind of lag on a network is called latency, the time between when the data is required and the moment it actually gets delivered. The more latency, the longer the delay, and the longer you have to stare blankly at your computer screen, hoping something happens soon. Latency affects some programs more than others. If you are sending an email, it may be annoying if you have to wait for a few seconds for the email server to respond, but that type of delay isn't likely to cause physical harm to you or a loved one. Applications that are adversely affected by latency have said to have high latency sensitivity. A common example of this is online gaming. Although it may not mean actual life or death, playing certain online games with significant delays can mean the ultimate demise of your character and you won't even know it. Worse, it can affect the entire experience for those playing with you. You can even get booted from the game servers. On a much more serious levels, applications like remote surgery also have high latency sensitivity. High bandwidth applications. Many of the applications we now use over the network would have been totally unserviceable in the past because of the high amount of bandwidth they consume. And even though technology is constantly improving to give us more bandwidth, developers are in hot pursuit developing new applications that gobble up that bandwidth as soon as it becomes, even in advance of it becoming available. A couple of good examples of high bandwidth applications are voice over IP and video streaming. Voice over IP, voice over internet protocol, describes several technologies that work to deliver voice communication over the internet or other data networks. In many cases, voice over IP includes not only voice but video transmissions as well. Voice over IP allows us to send voice, video and data all over the same connection to another application. Its most common application is video teleconferencing. Many companies are investing in voice over IP systems to reduce travel costs. Ponying up for pricey plane tickets, loading and rental cars add up fast. So investing in a good VoIP system that allows the company to have virtual conferences with people in another state or country pays for itself in no time. But sadly, voice over IP installations can be stressed heavily by things like really low bandwidth, latency issue, packet loss, jitter, security flaws and reliability concerns. And in some cases, routing VoIP through firewalls and routers using address translation can prove pretty problematic as well. Video applications. Watching a real-time video on the internet today is great if you have a decent high-speed connection. You can watch news, sports, movies and pretty much anything else that you watch on television. Although viewing digital media online is so common that anyone born after the year 2000 won't be able to remember a time when we had to watch videos or anything other than a computer. Again, this requires lots of bandwidth and an excessive use can cause traffic problems even on the most robust networks. Other real-time services. While VoIP and video traffic certainly require the most attention with respect to performance and latency, other real-time services are probably in use in your network. We're going to briefly look at presence, another example of real-time services you may not give a lot of thought to, and then I'll compare the use of Unicast and Multicast in real-time services. Presence. Presence is a function provided by many collaboration solutions that indicates the availability of a user. It signals to other users whether a user is online, busy in a meeting and so forth. If enabled across multiple communication tools such as IM, phone, email and video conferencing, it can help determine the communication channel on which the user is currently active and therefore which channel provides the best possibility of an immediate response. Multicast v Unicast. Unicast transmissions represent a one-to-one conversation, that is, data sent from a single device to another single device. On the other hand, multicast is a technology that sends information for a single source to multiple recipients, in far superior to using unicast transmission when it comes to video streaming and conferencing. While unicast transmission creates a data connection and stream for each recipient, multicast uses the same stream for all recipients. This single stream is replicated as needed by multicast routers and switches in the network. The stream is limited to branches of the network topology that actually have subscribers to the stream. This greatly reduces the use of bandwidth in the network. Uptime. Uptime is the amount of time the system is up and accessible to your end users. So the more uptime you have, the better, and depending on how critical the nature of your business is, you may need to provide 4.9 and 5.9 uptime to your network. That's a lot. Why this is a lot? Because you write out 4 nines as 99.99% or better. You write out 5 nines as 99.999%. Now that is some serious uptime. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.